Good morning. Good evening, my dear students. Welcome to the first video recording for the students from pre-algebra and basic math, seventh graders, for students from seventh grade. Today, we're going to start with a little introduction with the rational numbers. First, remember in math, we have the numbers in the number line. Obviously, we have integers, we have even numbers, odd numbers, we have decimal numbers, and obviously we have the rational numbers. But what is that concept? What does that mean, a rational number? Why it's so useful, the rational number in real life situations? Well, actually, in the real life situations, the fractions we can use like expressions to summarize a ratio or division between two quantities. Well, as soon as you can read in this whiteboard, the rational numbers or fractions are expressions that denote division between two numbers. Those numbers are named numerator and denominator. Well, as soon as you can read in the whiteboard, we have one single example of a fraction. The fraction is 2 feet. This 2 feet represents the upward number. I mean, in the first number represents the numerator, and below this horizontal line, we have the denominator. Well, but what is the difference between the numerator and the denominator? Well, actually, the numerator represents a total quantity of units, materials, units, what we're talking about in one singular situation, okay? And the denominator represents the quantity of numbers. The numerator must be divided for every math concept. Actually, you can have an example. If you really want to buy a pizza, when you buy a pizza, the actually the giant pizza, do you remember it has 12 slices, right? And at your home, there's only 3 people, including yourself. Well, if you really want to share that pizza in equal parts, the only thing that we have to do is divide 12 slices of pizza between the 3 persons that are living in your home. Okay, that what does that mean? That means every people or every person in your home, they would to receive 4 slices. Okay, this is the concept of the fractions. Divide the numerator that represents the 12 slides and divided by the 3 people, the 3 persons that are living in a home. Okay, and every one of them will receive 4 slices of pizza. Okay, but how we can classify these rational numbers? Well, these rational numbers can be classified in 2 ways: proper fractions and improper fractions. Well, to explain with more details this classification between them, we can see the 2 examples. The first fraction is 12 feet. That represents an improper fraction because the numerator will be greater than the denominator. That's why we're talking about the improper fractions. By the other hand, the proper fraction is the opposite. We have the beginning example. We have 2 feet apart, so one singular situation, okay? This is a proper fraction because every time that we have a number or numerator smaller than the denominator, we want to obtain decimal numbers, but less than the unit. I mean, the quantity like as the maximum values could be 0.9, 0.99, 0.9999, and so on, but never reaches the unit, at least, at least then the numerator and the denominator represents the same quantity. Example, if you have a fraction 5/feet, well, you can simplify that fraction divided by the numerator and the denominator. We have the unit. 10 divided by 10 or 10 over 10? Well, same happens. The numerator and denominator, we have both have the same quantity, so for that reason, the answer will be 1, the unit. But when the numerator is smaller than denominator, always we're going to take decimal numbers is smaller than 1. For example, if you divide 2 divided by 5, this fraction to fit, another way of saying is 0.2, okay? Because the numerator is smaller than denominator. And if you divide 12 divided by 5, obviously we're going to represent quantities superior than 5. So actually, the example, if you divide these two numbers, the answer will be 2.2. Okay, so well, actually 2 divided by 5, I'm making a mistake. This is not 0.2, this is 0.4 units in this situation. Okay, but you in the number line, as soon as you can, if you remember, the number line represents is the horizontal line that represents the integers, the real number, the number line. So this number line can be divided into parts, the positive numbers and negative numbers. Well, let's going to see an example. Let's going to create a number line and let's see what will be the place of the rational numbers or fractions. Okay, so let's going to begin. This is 0. We have the number 1, 2, 3, 4, 5 units, and so on. Okay, remember, to the right side I represents by numbers the positive numbers, and every time those numbers as moving far away from the number 0, the value will be increasing. This is when that's happened if and only if those numbers moves to the right side. By the other hand, when we're talking about the negative numbers, -1, -2, -3, -4, -5, and so on, well, it's the opposite. As a matter of in fact, okay, every time the number is moving far away for the number 0, increasing the distance between negative number for the number 0, these numbers in the number line will be decreasing because we're going to be smaller than 0. Okay, but in this situation, it's easy for us to determine who's going to be a smaller value, who's going to be a greater value when we're talking about whole numbers into the number line. But at the moment, we really want to know what will be the place of these rational numbers in the number line. Remember the number line. This is a place where it's going to line down positive, negative numbers, actually whole numbers, and decimal numbers. Okay, and the fractions is another way to express the decimal numbers without using decimals. Well, how we can explain that situation? For example, if you really want to graph the fraction to fit in the number line, it's easier because the only thing that we must do is divide 2 divided by 5. Okay, and you know, at the moment you divide 2 divided by 5, okay, let's see. We have to looking for one number multiplied by 2 that reaches 5 or that approaches to 5. That will be that's not possible because 2 is smaller. To obtain 5 is so smaller to obtain a value from the number 2. For that reason, the only thing that we must do is adding the number 0 right here and adding the number 0 in the quotient. And now we can divide this expression. I mean, we can divide 20 divided by 5. And one number multiplied by 5 reaches 20. That will be 4. 5 times 4 or 4 times 5 will be 20. And the remainder will be 0. What does that mean? That means the fraction to fit transform in decimal numbers will be 0.4 units. Okay. And in the number line, 0.4 units is a number located between 0 but smaller than 1. Obviously, I cannot graph 0.4 in the middle because in the middle represents the half value of 1 will be 0.5. So we can represent 0.4 onto this one. A little bit placed in the left side of 0.5. And here we are. We have the fraction 0.4 decimal numbers, or if you wish, you can write the answer like a 2 fit units. This is one example how we can graph a fraction. Actually, this is just when we explained a few seconds ago. This is the graph of the fraction, the proper fraction, when the numerator is smaller than the denominator. But what happened is this time we really want to graph the fraction 12 feet. Okay, remember this fraction that we call that one like a proper improper fraction because the numerator is greater than the denominator. What does that mean? That means that the decimal number that will be superior than the number 1. So let's divide 12 divided by 5. A number can multiply by 5 reaches the number 12. Okay, that will be 2. Because we cannot use in the number 3, because if you multiply 3 times 5, that will be 15, and 15 overpasses 12. But if you multiply 2 times 5, that will be 10. Okay, so 12 subtracting 10, that will be 2 units. But we can still continue dividing by this fraction. How can we do that? Simple. We can add a 0. This quote, this reminder, and a decimal point in the quotient. And a number multiplied by 5 gave us 20, which approaches to 20, will be the number 4. And 5 times 4 will be 20. Okay? And the remainder will be 0. And say happen. Well, how are we going to graph the expression 2.4? Well, the expression 2.4 will be located between the number 2 and the number 3. We cannot graph in 2.4 in the center because we're talking about the center. In the middle will be always represented by 0.5. And 2.5, that will be the center between 2 and 3. So the only thing that we must do is approaches that in the center a little bit, just a little bit approaches to the left side. And obviously we can represent the fraction. In this case, the proper fraction, a proper fraction, 12 feet. And we have those values, the fractions represents in the number line. Another example in what happened just in case we have fractions who's giving us negative values. Well, it's the same situation. Sometimes we have fractions that transform the numbers into whole numbers. Okay, just in case we got the graph the fraction negative 72 over 3. 72 over 3. we can simplify this fraction. Actually, this is a negative value and sometimes gave us the decimal numbers, but sometimes gave us a whole number. Well, obviously, this representation will be a negative value because if you remember the law of signs, every time that we have a positive quantity multiply a negative quantity, that gave us a negative quantity because negative times positive, that will be negative. So let's going to represent the division between them. To divide a negative quantity fraction, first of all, forget about it, the sign, okay? Let's take only the numbers. 72 divided by 3, okay? So number multiplying by 3 gave us 7. That will be 2 because 2 times 3 will be 6, okay? And 7 minus 6 will be 1. We're going to approach the number 2, and then we're going to have 12. Okay, and 12 divided by 3 will be 4, and the answer will be 12 minus 12 will be 0. So the negative 72 over 3, we can copy the negative whole number, and we have the number negative 24. We have this approximate, we have the number line located this way. Well, we have to draw 24 numbers located to the left side. But what happens if we are working with a little bit smaller numbers? Well, we can use, for example, negative 5 over 3. Or negative 5/3. This is also a proper fraction, improper fraction, sorry. So at the moment we must divide 5 divided by 3, you know, 3 times 1, 3. Well, we have 2 units. We can add a 0 decimal point, and we continue 6 times 3. That will be 18. We have 2 units, add the number 0, another 6, and 20 units, and so on, and until that will be a decimal number whose the decimal numbers shall repeat in the same period. Negative 1.66666. And if you really want to get this value, the number line, you can do it. How can we do that? Simple. Summarizing that expression or rounding that expression, no one decimal point after the whole number. I mean, instead to have negative 1.6666, we can round that expression like negative 1.7. And 1.7 will be negative value. Obviously, in that one will be approaches to negative 2 located over here, right? So, and this is going to be the fraction negative 5/3. Okay, so, and this is going to be the basic concepts of the rational numbers, the number line, how you can get the fractions in the number line, and how to identify the kinds of fraction, how we can classify the fractions in proper and improper fractions. Okay. Ok, ahora vamos a dar otra vez la recapitulación de todo lo que hemos dicho en español. Los números racionales también se le conoce con el nombre de expresiones los números racionales se conocen como fracciones. Esta fracción se denota como un radio o una cantidad que se va a dividir entre dos números. Esos números se pueden llamar como numerador y se les puede llamar denominador. Bueno, con un ejemplo teníamos esta fracción que es el número 2/5. 2/5. El número 2 representa el numerador y el número 5 representa el denominador. Pero, ¿qué es el numerador y qué es el denominador? Mencionaba de que el numerador representa una cantidad total de ciertas unidades materiales o cosas, depende de lo que estemos hablando de una situación, pero una cantidad total que tengamos disponible. Y el denominador nos sirve a nosotros para dividir o repartir en partes iguales y proporcionales esa cantidad. Ya, por esa razón decimos para cualquier concepto matemático, es decir, para cualquier fin que tengamos. Y utilizábamos el ejemplo de una pizza. Una pizza tiene gigante, tiene 12 rebanadas. Si usted hay 3 personas en su casa viviendo, incluyéndolo a usted, y usted quiere repartir esos pedazos de pizza en partes iguales, solo divide 2 entre 3 y tiene 4. Significa que a cada miembro de su familia o a cada individuo que lo acompañe usted en su hogar, le tocaría 4 rebanadas. Así de sencillo. Y cómo estos números racionales se pueden clasificar. Estos números racionales se pueden clasificar en dos partes, en una fracción propia y una fracción impropia. Como las imágenes son mucho más sencillas que las palabras, aquí tenemos dos ejemplos. Tenemos una fracción denominada 12 quintos. 12 quintos es una fracción impropia. ¿Por qué? Porque el numerador, o sea, el número que está en la parte de arriba, es superior al número que está en la parte de abajo. En este caso, 12 es mayor que 5, por lo tanto, es una fracción impropia. Y las fracciones propias es lo opuesto. Las fracciones propias es cuando el numerador es menor que el denominador. Y aquí usamos el 2 quintos como el ejemplo que nosotros hablamos desde el inicio, ¿verdad? Ahora, ¿qué papel fundamental juegan las matemáticas? Los números racionales o fracciones. Recordemos que la recta numérica es la casa, es el lugar donde alberga todos los números reales, ya sea positivos, negativos e inclusive los decimales. Tenemos lo que son las fracciones, que las fracciones, como le decía, es una forma abreviada de representar números enteros o decimales dentro de la recta numérica, donde en la recta numérica tenemos el 0 como frontera y tenemos los números a la derecha positivos que a medida que se alejan de 0 va incrementando su valor, y los números negativos que a medida que se alejan del 0 su valor va decreciendo. ¿Y cómo es eso que alberga? Pues enteros y decimales. Es muy sencillo. Imagínense, si yo quiero representar una fracción impropia, como por ejemplo 2 quintos en la recta numérica, muy sencillo, lo único que usted tiene que hacer es dividir la cantidad 2 entre 5. Pero como el 2 es inferior al 5, usted conoce que podemos agregar un 0 en el dividendo para tener y 0 en el cociente para poder incrementar ese valor. Y una vez teniendo esto en cuenta, podemos encontrar un número que multiplicado por 5 nos dé 20 o se aproxime al número 20, y ese número sería el 4. 4 por 5 es 20. Y 20 menos 20 nos da 0. Entonces, ¿qué significa? De que la fracción 2 quintos, que es una fracción impropia, se puede convertir en un decimal como 0.4. Y ese 0.4 se puede graficar entre 0 y el 1, no exactamente en el centro, porque en el centro sería el punto 5, pero un poquito, se grafica un poquito a la izquierda. Tenemos, por otro lado, la fracción impropia, 12 quintos, que si dividimos 12 entre 5, ya conocemos el proceso perfectamente, nos quedaría el valor 2.4. Y el 2.4 estaría localizado entre el 2 y el 3. Mire, aquí tenemos ejemplos de dos decimales, pero ¿qué hay con los números enteros? Bueno, y los negativos. Tenemos esta fracción impropia, negativo 72 tercios. Al momento que usted lo divide, nos queda el entero 24 negativo, que podríamos crear una escala más grande de la recta numérica, y este descansaría perfectamente en negativo 24. Entonces ahí estamos denotando que las fracciones también pueden albergar números enteros, tanto positivos como negativos. E inclusive tenemos las fracciones de números periódicos mixtos. ¿Qué quiere decir periódicos mixtos? Que después del punto decimal ese número se repite infinitamente, como por ejemplo tenemos el número negativo 5 tercios, que eso vendría siendo 1.6666, pero negativo en este caso, pero para representarlo en una recta numérica, no lo vamos a colocar 1.666 infinito. Lo único que usted tiene que hacer es redondear el primer número decimal al inmediato superior, que en este caso sería el número 7. ¿Okay? Bueno, mis estimados estudiantes, esto ha sido todo por hoy. Una pequeña introducción, números racionales, su clasificación y qué papel fundamental juegan las matemáticas en una recta numérica. Bueno, si el video le gustó, denle like, suscríbase y comparta con el resto de los alumnos en su comodidad. Tengan muy buenas noches. Dios los bendiga, los guarde y los cuide.